what I saw near my house, that these distribution lines, these electrical poles are tilted or lean towards the ground, and this tilted condition of the pole is not favorable, as we all know that. So what is the effect on the electrical quantities? Let's see how it is going to affect the electrical quantities or electrical effect. Inductance per phase due to uneven spacing. As we can see that these electrical poles, the conductor from which they are coming, these three conductors are having the unequal spacing in between them. Let's use the formula. L is equals to 2 into 10 to the power of minus 7 log T equivalent by R dash Henry per meter. Actually here T equivalent is the geometric mean distance between the conductor. R dash is equals to 0.01 meter, which is the effective conductor radius for ACSR. So we saw that inductance per phase due to uneven spacing in between the conductor. Let's have some numerical values. Example, in case of the normal spacing, R2Y is equals to Y2B is equals to 1 meter and R2B is equals to 2 meter. This is the three live wires or phase wires R, Y and P connection. So D equivalent is equals to cube root of 1 into 1 into 2 is equals to 1.26 meter. Let's now calculate the inductance, which is normal inductance. Using the same formula, we will get 9.68 into 10 to the power of minus 7 Henry per meter. Now doing for the abnormal spacing, that is in our condition, in our electrical poles, as we saw. Let's say R2Y distance become 1.4 meter, Y2B is equals to 0.6 meter and R2B is equals to 2.2 meter. So in this case, D equivalent is equals to cube root of 1.4 into 0.6 into 2.2, which is approximately equals to 1.21 meter. And hence doing the calculation for abnormal inductance, we will get 9.6 into 10 to the power of minus 7 Henry per meter. So what we saw, that small spacing difference gives to small change in inductance, which has an effect on impedance and current flow. Let's see how. Line impedance. Z is equals to R plus J omega L is the formula for the line impedance in the transmission line, as we all know that. So let's say R is equals to resistance is equals to 0.5 ohm per kilometer. So 0.0005 ohm per meter. And the frequency is equals to 50 hertz. Thus omega is equals to 2 pi f is equals to 340. Now the normal impedance is equals to, using the formula, we will get 0.0005 plus J 0.000304 ohm per meter. Now let's go for the abnormal line impedance. Doing the same, we will get 0.0005 plus J 0.000301 ohm per meter. And hence we saw that the impedance difference per meter is small but adds up over kilometer. So it is very small quantity, that is line impedance, if we are talking about a very small distance like distribution lines, because in this case the span length in between two poles is very less. Voltage drop, V drop. What is a voltage drop? If there is a line spacing, uneven line spacing in between these two poles, V drop is equals to I into Z. Assuming, let's say I is equals to 50 ampere, then V drop, normal voltage drop is equals to about 0.0029. Normal voltage drop, doing the calculation, we will get about 29 volts over 1 kilometer. So voltage drop from 415 volts source gives to 386 volts, and still within range for domestic loads, but risky for the pumps, because pump are going to use the 3-phase connection, isn't it? So 3-phase connection, it is very hazardous, but for the single-phase connection, like most of our load, it's not going to affect, that is line spacing or uneven spacing. Let's go to the next point, that is current imbalance due to the impedance variation. Because of the line spacing, inductance effect, impedance effect, and from impedance there is a current imbalance. So let's see how. Voltage per phase is equal to 230 volt. Let's assume, and actually it is the actual value, isn't it? Impedance is equal to ZR is equal to 0.5 plus J 0.3, and for ZY is equal to 0.52 plus 0.28, and for ZB is equal to 0.48 plus J 3.32. So after doing the calculation, we will get IR, current through the R phase, is equal to 394 ampere, and current through the Y ampere is equal to 390 ampere, and current through B phase we will get 399 ampere. So even a small change in the inductance causes the imbalances of about 5 to 10 ampere in the high load setup. In the high load setup, it is going to affect, because all the 3-phase wire has to use them.